Okay, my dear children, we discussed several things related with the lesson in our earlier chapters. So this is our final chapter regarding the lesson. So within this chapter, we'll be discussing about the neutralization, right? Neutralization. So before we are going to study about neutralization, we'll be observing about acidic, basic and neutral substances. So you are given with an activity in here, right? You are given with an activity here. So we'll see what are the materials that we need in conducting this activity. Okay, so to identify the acidic, basic and neutral substances, you are given with several substances here also, right? So we'll be identifying the acidic and the basic and the neutral nature of the substances first. So first of all, you'll be needing some hydrochloric acid. Hydrochloric acid. Then some sodium hydroxide. Sodium hydroxide, right? Sodium hydroxide. Hydrochloric acid, sodium hydroxide solution. Then sodium chloride solution. Sodium chloride, in simple, salt solution, right? Salt solution. Then we'll be needing some boiling tubes or test tubes. Then litmus papers, right? Litmus papers, right? Litmus papers. Then pH papers. pH papers. These are the indicators that we are going to use, right? Indicators. We will be needing litmus papers and pH papers, right? Then the next one is phenolphthalein, right? The next one is phenolphthalein. So phenolphthalein, pH papers, litmus papers, all of these things are considered as the indicators, right? Indicators. Indicators are the things which provide us with a certain type of a color change, right? With the presence of an acid, base or else a neutral substance, right? So these are the materials. Hydrochloric acid to identify the nature of acids. Sodium hydroxide solution. You know that if hydroxide is there, then it is a base, a type of a base. Sodium hydroxide, a base, good base. Then sodium chloride solution, common salt that we use in our day-to-day life, is a type of a neutral substance. Boiling tubes, in order to put these substances. Then litmus papers, pH papers and phenolphthalein as our indicators to test with each of these substances, right? Now let's see how to conduct this activity. Okay, so this is the method in doing the experiment, right? So the method is given. take hydrochloric acid solution, sodium hydroxide solution, and sodium chloride or salt solution separately into 3 test tubes. First of all, you have to take these 3 solutions separately into 3 test tubes like this. A. Hydrochloric acid, B. Sodium hydroxide, C. Sodium chloride. The 3 solutions. Test these 3 solutions with red litmus papers. You have to insert a piece of red litmus and observe the changes. Okay, first of all, observe with red litmus. Test these 3 solutions with blue litmus papers, then with the blue litmus. Right? You have to observe these things or observe the color change with the blue litmus papers. Then in the third one, test these 3 solutions with pH papers. Right? So when you are checking with pH papers, make sure to take that indicator scale and keep it alongside with the color change so that you can get a good scale, I mean like a reading of pH value. Okay, so finally add 2 drops of phenolphthalein to these solutions and record your observations. So by using each of these indicators, we have to test for these substances. So hydrochloric acid, sodium hydroxide, and the sodium chloride solution. Then we have to observe and record the changes right then. So this is the way of conducting the experiment, my dear children. So we'll head on to the lab. We'll conduct the experiment and let's see what are the changes that we can observe. Right, my dear children. Now in this activity we'll be observing some acids, some bases, and some neutral substances. As examples, we took solution A, this one, solution A, HCl solution, hydrochloric acid, HCl means, right? Hydrochloric acid solution. Second one, sodium hydroxide solution, sodium hydroxide solution, hydrochloric acid solution, sodium hydroxide solution. C, right? C, sodium chloride solution, common salt solution. Third one. Once again, A, HCl, B, sodium hydroxide, C, sodium chloride or common salt. Right. You know that HCl or hydrochloric acid, in the name itself it says acid, right? So hydrochloric acid is an acidic substance. Sodium hydroxide, hydroxides. So in the earlier grades also you have identified bases. So most of the bases ends with hydroxide part. So sodium hydroxide is also a type of a strong base that we use in our laboratory. So this is sodium hydroxide solution B. C, our common salt solution, right? So if you take common salt do not have any of acidic or basic properties. So therefore, common salt is referred as a neutral substance. It's a neutral substance. So now what I'm going to do is, I'm going to test these solutions by adding these special papers. First of all, I have piece of papers which are in blue color, right? So these pieces of papers which are in blue color are referred as Blue litmus, you already know these things. Blue litmus. In the materials also, I told you when I was doing the activity on the classroom, I told you that for the materials we'll be needing these litmus papers. So blue litmus, then these red color paper stripes are red litmus, red litmus. Then this yellow color paper stripes, pH papers, pH papers. And to identify the pH scale and the relevant color, we have an indicator with the relevant colors. Okay. So first of all, I'm going to use this A solution. So we know that A solution contains HCl, right? So we'll add some amount of A solution into this A Petri dish, right? Then I'm going to add B solution to the B Petri dish and C solution to C Petri dish. Once again, A contains hydrochloric acid, sodium hydroxide solution, sodium chloride or common salt solution. Right, my dear children. So I'll remove these papers to a side and keep it in the Petri dish that I have in here. So first of all, I'm going to take blue litmus. So we'll add blue litmus to each of these Petri dishes and we'll observe what will happen to the color of blue litmus paper. So we'll add a piece of blue litmus to A, piece of blue litmus to B, and finally to C. Now I am going to take each of these litmus papers. So now here, when you take these acidic solutions, it's not wise to touch these solutions from your bare hands. But in these cases, we have added water and we have diluted the solution very well. So it's not that much risky. But remember, it's not wise to touch these chemicals with your bare hands. Okay? Remember it, my dear children. So first of all, I'm going to take this one that has blue litmus. So this is the observation with the blue litmus thing. Okay. A means this acidic solution or the hydrochloric acid turned blue litmus to red color. So acids will turn blue litmus to red color. So this is a unique feature of acids. We can use blue litmus papers to identify acidic solutions. With the presence of an acid, blue litmus turns to red color. Second one, we're going to add red litmus, right? So we'll add a piece of red litmus then. Piece of red litmus, piece of red litmus, and the piece of red litmus. Right then. So here, let's see what has happened to the red litmus. With the acidic solution HCl, this is what has happened to the red litmus. Actually, there is no observation. It has the original color, right? There is no observation. It has original color, right? Red litmus. Red litmus has turned into blue color. See, red litmus has turned into blue color. Red has turned to blue color with the presence of a base. So you know that B solution contains sodium hydroxide, which is a strong base. But here up to a certain level, we have diluted it, right? But however, it contains a base, so therefore red litmus is getting converted into blue color, right? Red litmus is getting converted into blue color with the presence of a base. That's a unique feature of base, and we can use this activity to identify bases in our day-to-day life by using these litmus papers. So when you add a red litmus to a base, red will turn to blue color, like in the case in here. Okay. Now the neutral substance, which is salt. So there is no difference with the color. The red is going to stay as the same in red color, right? Okay, now the third and the final paper, pH papers. So now I am going to add a piece of pH paper to each of these containers. So we'll add pH papers then. pH papers. Kind of a yellow color paper stripe, pH paper. So we'll add pH papers. One to the acid, one to the base, and one to the neutral substance. So we'll give it some amount of a time. So here, now let's take out these papers and we'll see our observations. To get our observations more accurately, I'll place this indicator in front of you. Right, I'll place the indicator in front of you. Right, my dear children, now let's see the color change. So I have placed the indicator here. Now I'm going to take the pH paper and place it here. Let's see a value. So it's around like between 3 and 5, right? It's between 3 and 5. Between 1 and 3, like pH value is about 2. Yes, pH value is about 2. So here, see the color? The pH value is about 2 in here. Right? pH is about 2. Right? So I'll keep the pH paper here. So in the first solution, where we use hydrochloric acid, pH value is about 2 and it is showing a red related color, like a yellow, orangish yellow kind of a color. Right? So the second one, sodium hydroxide solution with pH paper. See, it is showing a good blue color. See, pH value is about 9, 10. It's about 9 or 10. See, it's showing a good blue color. So bases, if you take bases, bases are showing blue related color. It's quite easy to remember. B, bases. B for blue color. See? Blue color. Blue related color. Base. Then the final one. The pH paper which is on the sodium chloride solution. So we'll compare the color. So it has like about, see here, it has a color about 5 to 6, right? 5, 6. It's greater than 5. It has some kind of a green color, some amount of a green color. So this 5 in the fifth color, you can observe the fifth color, 1, 2, 3, 4, fifth color. It has a light yellow color, but the paper which I have in my hand is having some amount of a greenish yellow color. So it's around, it's greater than 5 but less than 6, right? It's nearly about 7. We can say that it's nearly about 6 to 7, the pH value, right? So these are our observations from this experiment, right? So when you add in pH papers for acids, it's giving out a red related color. So the pH value of an acid is around 1, 2, 3 and 4. I mean, like if you take the pH value of an acid, it's less than 7 to be in exact, right? It's less than 7, right? 6 is also more related with neutral substances. But if the pH value is less than 5, then it is acidic, right? So acid is giving out a red related color, right? So blue litmus is getting converted to red color with the presence of an acid, and pH papers are also showing a red related color like orangish yellow or red color is getting we can observe like that kind of a color with the pH papers as well when you insert a pH paper into a acid solution. If you take bases, now bases have a blue related color like purple, light blue, blue color, dark green. So those kind of colors are blue related colors. So bases show these blue related colors, right? So here you can observe these things are very clear to us. All of these substances are getting, all of these papers are getting converted to a blue related color, right? So red litmus is getting converted to blue color with the presence of a base, right? And pH papers also getting converted into blue related color with the presence of a base. Now the third one, the neutral substance. There is no distinct change when you add these papers to neutral substances. There is no distinct change, right? Red litmus remains in the red color, blue litmus remains in the blue color, and also pH papers is showing some amount of a color which is related to pH value 6, 7, greater than 5, but more closer to 6 and 7, right? So these are the observations that we can take from the experiment if you add these pH papers and litmus papers for the solutions of acids, bases and neutral substances. Right, my dear children. Now I'll remove these petri dishes. I'm going to remove these. Right? Okay. I'll wipe out the surface so that you can observe these things very clearly. Now, I'm going to take each of these solutions once again. I'll be needing each of these solutions once again. Here we are going to observe the color change of these solutions with the presence of phenolphthalein. Here I have phenolphthalein solution. Phenolphthalein is a special indicator that can be used to identify bases. With the presence of a base, phenolphthalein is giving out a pink color. The normal color of phenolphthalein is actually, now I have a dropper with me. So let's get some amount of phenolphthalein to the dropper. See, the actual color of phenolphthalein is colorless. See, there is no color.
There is no distinct color in phenolphthalein. So with the presence of a base, phenolphthalein is giving out a pink color. Now let's only with bases. Okay, remember the pink color can be observed only with bases. Now let's add a drop of phenolphthalein to each of these vessels and let's see whether we can get this observation. So first of all, I am going to use the leftover part of this hydrochloric solution and I am going to add a drop of phenolphthalein. Right. There is no change in the color. So I told you that we use phenolphthalein just to identify bases. So with bases, phenolphthalein is giving out a pink color. So we'll keep it in here. A solution, HCl. Now let's try phenolphthalein with B. You know that phenolphthalein is showing out or it's giving out a pink color with bases. Now B solution is sodium hydroxide. B solution is sodium hydroxide. Sodium hydroxide is a good base. So when I'm going to add phenolphthalein to this base, it should give out a pink color. We'll see. Yes. See, we can clearly observe it is giving out a good pink color. So bases can convert this phenolphthalein indicator to a pink color from colorless solution. Now the final one, the third one, sodium chloride solution. We'll add phenolphthalein to the sodium chloride as well. There is no observable change. Right? There is no observable change. It remains in the same color. So therefore, we can say that to identify bases, we can use this phenolphthalein indicator. So phenolphthalein is a substance that can turn a certain base into a pink color, right, from the colorless solution. So sodium hydroxide is a good base. Therefore, color of phenolphthalein is getting converted to pink color. Right, my dear children, then we'll head on to the classroom and we'll discuss further things related with the lesson.
Right, my dear children, so we conducted the experiment and we got several observations related with the experiment over there. So let's see what are the observations that we took from the experiment. So here, first of all, the solution A, if you take A solution, solution A turns the blue litmus paper into red color. Right? It's going to turn blue litmus paper into red color. Solution A does not change the color of red litmus. Red litmus color remains the same. You know, my dear children, if you take the red color is the usual acidic color. If you're going to put a piece of pH paper into an acid solution, the color of the acid solution or the color of pH paper is going to change into red color, right? So acid color is usually considered as the red color, right? So therefore, when you add blue litmus into an acid, blue litmus is going to turn into red color, but there is no such change in red litmus, right? So here it is given, the solution A does not change the color of red litmus. Solution A turns blue litmus into red color. When examined with a piece of pH paper, a value less than 7 is obtained. When you are going to examine it with a pH paper, value less than 7 is obtained. It's obvious because it should be a base. It should be an acid. If it is an acid, then the pH value is less than 7, right? Solution A contains hydrochloric acid. So it's a type of an acid. So if it is an acid, we know that the pH value should be less than 7, right? It should be less than 7. On addition, phenolphthalein it stays colorless. On addition of phenolphthalein, it stays colorless. So with phenolphthalein also, there is no color change because we use phenolphthalein to observe bases. With bases, phenolphthalein is going to give a unique pink color, right? So my dear children, hydrochloric acid is an acid. So therefore, we can't observe any kind of a change, any kind of a color change with the presence of phenolphthalein with that acid. Okay. So the second one, solution B does not change the color of blue litmus. It doesn't change in blue litmus into a different color. It turns red litmus into blue. So specialty in here is that it's going to turn red litmus into blue. So my dear children, if you take a base is going to show a unique blue color if you add a piece of pH paper into it. If you add piece of pH paper into a base, it's going to show a unique blue color, a blue related color like violet, blue, dark blue kind of a color. So here also red litmus is getting converted into blue color. So we can conclude that solution B, which got the sodium hydroxide solution, is a type of a base, right? So it turns red litmus into blue. When tested by a pH paper, the pH value is greater than 7. pH value is greater than 7 if you are going to test it with pH paper. Here the phenolphthalein thing is not given. It's because that, my dear children, in the earlier case it is colorless, no? Can you remember what's the change of color in phenolphthalein with the presence of a base? With the presence of a base, phenolphthalein is showing a good pink color, right? It's showing a good pink color, a wonderful pink color. Usually phenolphthalein is colorless. There is no color in phenolphthalein, but with the presence of a base, with the presence of a basic substance, color of the phenolphthalein is getting converted to unique pink color. So we'll write it down in here. It's a special indicator. Phenolphthalein is a special indicator that can be used to identify bases. So with the presence of a base, phenolphthalein is getting converted into a pink color. So sodium hydroxide or the solution B, there is a basic substance, right? Solution B contains a basic substance. So with the presence of that basic substance, phenolphthalein indicator is going to show a pink color. So we can write it in here, right? Phenolphthalein changes into pink color. I'll use that pink color pen to indicate the pink color. Right? Phenolphthalein changes into pink color with B. Right? Phenolphthalein changes into pink color with B. So when you put B solution into phenolphthalein, color of phenolphthalein is getting changed into pink color, my dear children. Right? So by these two experiments or by these two observations, we can clearly say that this is an acid and this is a base. Then the third one, C. So here C does not change the color of blue litmus or red litmus. C is not changing color of red or blue litmus. C contains sodium chloride solution. You know that C is the one which contains sodium chloride solution. So C does not change the color of blue litmus or red litmus. The color it gives with the pH paper corresponds to 7, not exactly 7, up to a certain extent, right? It's like much closer to 7, okay, much closer to 7. It does not show a color change with phenolphthalein. With phenolphthalein there is no color change, right? So we can say that C solution or the C vessel contains a neutral substance. So this is neutral. So acid, base and neutral. Finally, we can conclude the acidic, basic and the neutral nature of the substances in A, B and C. So A is a type of an acid, B sodium hydroxide, a type of a base, C sodium chloride, a neutral substance. Right then, conclusion. From the above observations, it can be identified that solution A, hydrochloric acid solution, acidic. Solution B, sodium hydroxide solution, basic. Solution C, sodium chloride solution, neutral. So solution A, which contains hydrochloric acid, has an acidic nature. Solution B, which contains sodium hydroxide, has a basic nature. Solution C, which contains sodium chloride solution, has a neutral nature. So this is the acidic, basic and neutral nature of these substances or in these solutions, right? So we have got an idea about acidic, basic and neutral substances, my dear children. Right, now let's see what are the other things contained in this lesson part. So we are investigating what type of a change occurs when an acid is added to a base. When you are going to add an acid with a base, what type of a chemical change is going to occur? What kind of a change is going to happen, right? We are investigating the change that's going to occur when you are adding an acid with a base. So when you are doing this experiment, you will be needing these tools or materials. A beaker. A beaker. Then you'll be needing phenolphthalein as an indicator. Right? Phenolphthalein as an indicator. Then we'll be needing a dropper. Right? We'll be needing a dropper. Right? We'll be needing a dropper to drop these substances dropwise into a different solution, right? To add dropwise, we'll be needing a dropper, right? Then sodium hydroxide solution. Sodium hydroxide solution. Sodium hydroxide solution. And finally, some hydrochloric acid. Right? Hydrochloric acid. So these are the substances that we need, my dear children. So we'll be needing a beaker, a dropper, some sodium hydroxide solution, hydrochloric acid solution, phenolphthalein as an indicator, right? Phenolphthalein as an indicator. So these are the substances that we need in conducting this activity. So let's see how to conduct this activity then. Right then, the method. Pour dilute sodium hydroxide solution. Diluted means less strength. By adding water, we can dilute any kind of a solution. Pour dilute sodium hydroxide solution to a beaker. Add a few drops of phenolphthalein into it. You have to add sodium hydroxide solution into a beaker and we need to add phenolphthalein. So as soon as phenolphthalein is going to hit sodium hydroxide, color of phenolphthalein will change into pink color, right? It's because that in the earlier case also we wrote that thing. With the presence of a base, phenolphthalein is going to change into pink color. Then add dilute hydrochloric acid dropwise into it using a drop-in pipette. You can use a drop-in pipette or else a small bit of a dropper like in the earlier case. You can use a drop-in pipette or else you can use a dropper, a simple dropper, right? So using a drop-in pipette or else a dropper and observe the color change in the solution. Now we have to add dropwise. Hydrochloric acid should be added dropwise, my dear children. Not a whole solution, but we need to add dropwise and we have to observe the color change. That's why we need to add dropwise. Okay. When the acid added to the pink color, when the acid is added, the pink color of the solution gradually decreases and at a certain moment the solution becomes colorless, right? So at a moment you can see that at a certain moment you can see that when you are going to add this, right, when you are going to add this hydrochloric acid solution into the system or into the sodium hydroxide solution, at a certain moment the color of phenolphthalein is going to change into colorless solution, right? This indicates that when an acid is added to a base, the basic property of the base gradually disappears. So here, when I am going to add the substance, it's observed that the pink color is going to disappear at a certain time, right? It's because that when you are adding an acid to the base, both the acidic and basic features cancel off to form neutral substances, my dear children, right? So this is the way of conducting our experiment. We'll head on to the lab. We'll conduct the experiment and let's see whether we can get a colorless solution from this setup. Right, my dear children. Now in this experiment, we'll be observing what kind of a reaction is this neutralization reaction, right? Or what kind of a change is this neutralization change. So in a neutralization change or neutralization reaction, an acid is reacted with a base or a base is reacting with an acid. So when reacting acid with a base or else a base with an acid, both the acidic and basic features disappear to form neutral substances. So I have these things with me, these materials with me. So we are going to conduct a small bit of an experiment to show that the neutralization reaction is going to occur or substances are getting neutralized when you are adding an acid with a base. Right. So first of all, I'll be needing some amount of sodium hydroxide solution. Sodium hydroxide solution. So this is sodium hydroxide solution. Some HCl solution. HCl means hydrochloric acid. So some hydrochloric acid.
right? Some amount of hydrochloric acid. A vessel, right? A vessel to dissolve or to, like add these substances separately and to get a clearer observations. And I have another two separate beakers to measure these liquids separately. And finally, I have a dropper plus some amount of phenolphthalein as the indicator. So first of all, we'll measure about 30 milliliters of sodium hydroxide, right? To get more accurate observations very clearly. So we'll get about 30 milliliters of, right? We'll get about 30 milliliters of sodium hydroxide solution to this smaller beaker. So we need to keep the beaker at the eye level when you are measuring liquids. 30 milliliters to be exact. Right. So I have measured 30 milliliters of sodium hydroxide solution. Right? 30 milliliters of sodium hydroxide solution. See? I have 30 milliliters of sodium hydroxide. Then we'll take HCl and we'll measure some amount of HCl. Right? We'll add some amount of HCl. Here we don't know exactly how much of HCl is needed for this chemical reaction. So therefore I'll add like some amount of HCl to here. Right then. Now I am going to add this earlier measured sodium hydroxide solution to our vessel. Sodium hydroxide solution. Now, gradually, before that, to get an observation, we need to add our phenolphthalein solution. So you know that phenolphthalein is giving out a pink color with the presence of a base. So we'll add phenolphthalein into this, right? Have to mix it very well, right? To get more clearer color. So we'll mix it. So I'll add another drop. Right. See, phenolphthalein is giving a good pink color with the presence of a base. So I took sodium hydroxide. So it's giving a good pink color with sodium hydroxide. Right. Now, I'm about to add previously measured hydrochloric acid to this solution of sodium hydroxide. Observe what happens when I'm going to pour this liquid into the vessel. Okay, this liquid is hydrochloric acid, HCl. So we'll add very gently, right? Right. So we'll mix it. Now, when I'm adding this hydrochloric acid, at a certain point, if the solution is getting neutralized, if the basic features are getting disappeared, then this solution should become colorless, because phenolphthalein is originally in colorless situation, right? So when adding acid, it should be turned into a colorless solution. So we'll see whether it is getting colorless, whether it is getting into a colorless solution or not. We'll add more. Remember to add it slowly, my dear children. Okay. Right. So we'll mix it. Let's add once again another like 2 or 3 drops. Right, you can see the color is getting changed somewhat. Right, just 1 drop once again. Right, now it's difficult to put by using this container or this smaller beaker, so therefore I'll use the dropper. So say let's take some amount of HCl. Right, you can see the color is getting disappeared gradually. In the earlier, it was like dark pink color, but now gradually the color is getting decreased. So we'll add drop by drop. See, the color is gradually decreasing. We'll add another drop. See, the earlier it had a good pink color, but now the color has reduced somewhat. See, you can observe now the color has decreased dramatically. Now in the earlier situation it had a good pink color, but now it has a very less pink color. We'll add another drop and we'll mix it. See, now the color even drops down. So here now you can see in this solution the pink color is very less, means now it is about to get neutralized. It has some amount of a basic nature, as it is in some amount of a pinkish color. See, it has some amount of a pinkish color, so it has some amount of a basic nature, right? So when adding acid to this sodium hydroxide solution, you can observe the colorless or color is getting dramatically changed into the initial color of the sodium hydroxide solution, which was colorless, right? So it doesn't have any basic or acidic features when I'm going to add, when I'm going to add these HCl or else acidic substances to sodium hydroxide solution. The basic nature of the sodium hydroxide solution gradually reduces. That's why the pink color is also getting reduced gradually, right? So we'll mix it once again and we'll add another drop to see what will happen to our solution. Right, my dear children, now you can observe the color has got disappeared totally, right? Means that now if you check this solution, there is no pink color in it, means that this solution has become now a neutralized substance. That's why there is no pink color. Initially it had pink color because it contains sodium hydroxide solution. So when I'm adding hydrochloric acid into the sodium hydroxide solution, gradually the pink color decreased and it took a colorless solution, right? Now it converted into a colorless solution. It's because that there is no acidic or basic features within this solution that I have in my hand right now. So we can finally conclude that from this experiment, by adding acids with bases, we can neutralize or we can cancel off both acidic and basic features. Right, my dear children, now see, you can observe the colorless solution. Now I am going to show that when I am going to add some amount of sodium hydroxide back to this solution, I am going to add some amount of sodium hydroxide back to this solution once again. Now this is the solution that we had, right? This is a solution that we have right now. This, I told you that this solution is now a colorless solution. Earlier it had a pink color. Now it is colorless. It's because that this is a neutral substance right now. That's why phenolphthalein can't give any color change, because with neutral substances, phenolphthalein can't give any color change. So I'll add just 1 of 2 drops of sodium hydroxide solution back to this solution once again. See, as soon as I am going to add sodium hydroxide solution once again, the color is going to reappear. See, once again color is going to reappear. Means that once again the basic nature of the solution is going to turn back on. If I am going to add more, see, if I am going to add more, then once again it will take the initial dark pink color. See, so when I am inserting this hydrochloric acid once again, it will turn into like a colorless solution. See, right. So we can say that when you are reacting or when you are mixing an acid with a base, both the acidic and basic features disappear to make neutral substances. So children, will head on to the classroom and will write down our observations and our conclusions from this experiment. So my dear children, we conducted the activity. When I was adding that HCl solution or hydrochloric acid solution dropwise into the container, right, I could observe these 3 states of colors in 3 different occasions. So I have placed a figure in here so that you can clearly observe. This is the first color, right? Phenolphthalein added with the sodium hydroxide solution to obtain a pink color. This is the second one. Here when you are comparing these two, you can see that the color of the solution has got diminished somewhat. Color has got reduced somewhat. This one has a good pink color, but here the pink color is somewhat less. In the third one, the pink color has got disappeared and there is no pink color at all. So these are the 3 states of the solution. When I was doing the experiment also, you could see it, right? So my dear children, let's see what are these states. So in the first one, A. In A, sodium hydroxide solution with a few drops of phenolphthalein. This is the initial solution which we took. In B, neutralized to some extent due to the addition of an acid. We added an acid now. So when acid is going to add with a base, acidic and basic features are going to disappear gradually in making neutral substances. So this process is referred as neutralization. So here the basic properties of sodium hydroxide is neutralized up to some extent when adding hydrochloric acid solution. How can you say that? Because the pink color of the solution is getting gradually reduced when I am going to add hydrochloric acid. When you add in further hydrochloric acid into the solution is getting totally neutralized and a colorless solution can be observed, right? Colorless solution can be observed. So these are the three states of the solution, three colors of the solution that we can obtain finally, right? Initial solution which has a basic nature. To show the basic nature, phenolphthalein has got a pink color. Intermediate state, when I'm going to add hydrochloric acid, it's showing out an intermediate state where the basic feature has got neutralized up to some extent. Third and the final one, totally neutralized. There is no basic or acidic features. So therefore the solution has got colorless, right? So these are the three observations at three different time intervals, my dear children, right? So here you can see when an acid is added to a base or base is added to an acid, their acidic and basic properties decrease, and at a certain point acidic and basic properties totally disappear. So when you add in an acid with a base or else base with an acid, at a certain level both acidic and basic features are going to disappear, right? Both acidic and basic features are going to disappear at a certain instance. This process is called the neutralization. So this process is called as the neutralization, my dear children. So neutralization is the process where we are going to disappear or we are going to extinguish both acidic and basic features in a certain substance. So during that process, if it is a base, we need to add an acid. If it is an acid, we need to add a base, right? So acids and bases, due to having opposite features, when they are mixed each other, both the acidic and basic features disappear to form neutral substances. This whole process in making neutral substances by mixing an acid with a base is called as the neutralization. Neutralization. So you know that sodium hydroxide is a base. Sodium hydroxide is a base. Hydrochloric acid is an acid. So hydrochloric acid is an acid. When these two react, when these two are going to react, sodium chloride and water are formed, which are neutral substances, right? So my dear children, during the reaction or during the chemical change between hydrochloric acid and sodium hydroxide, the products which are getting created are sodium chloride, common salt, and water. We know that sodium chloride has a neutral nature. In the earlier case, when we are discussing about the acidic, basic and neutral features of materials,
We took a sample of sodium chloride. We add several indicators into it. We use a pH paper. pH value is nearly 7. We add a red litmus. Red color remains the same. We add a blue litmus. Blue color remained the same. We add some amount of phenolphthalein. Phenolphthalein remained the same. So my dear children, we can say that sodium chloride is a neutral substance. That's why indicators are not giving out a color. And if you check with the pH scale, pH indicator, it is showing a value which is nearly equal to 7. So sodium chloride is a good neutral substance. So during the reaction between sodium hydroxide with hydrochloric acid, what are the products which are getting created? Sodium chloride. Sodium chloride, which is a neutral substance, plus the second substance is water, right? Both the substances are neutral. Both the substances are neutral. So we'll write down in here what are the products which are getting created. So here you can write sodium hydroxide, hydrochloric acid, hydrochloric acid. So what are the products? Sodium chloride, sodium chloride, sodium hydroxide plus hydrochloric acid is going to create sodium chloride plus water. So here both the substances are neutral. Both the substances are neutral. Hydrochloric acid, sodium hydroxide, base. So when you add an acid with a base, my dear children, neutral substances are getting created, or both the acidic and basic features disappear to form neutral substances, right? So when you react sodium hydroxide with hydrochloric acid, base with an acid, sodium chloride and water are the products which are getting created. Sodium chloride and water are neutral substances. So acid plus base is getting converted into neutral substances. Right then, this reaction between an acid and a base is a chemical reaction. It's obvious to us. New substances has got created, right? New substances has got created. Earlier it was sodium hydroxide and hydrochloric acid. Now sodium chloride and water. How can you say that? How can you prove? By using that pH paper, right? By using the color of phenolphthalein. Phenolphthalein indicator changes to colorless. So there is a color change. If there is a color change, you know that that should be a chemical change. So my dear children, this reaction between an acid and a base is a chemical reaction, and it is referred to as a neutralization reaction. So this is referred as a neutralization reaction. Right then, instances in which we happen to meet acid-base neutralization in day-to-day life. So in day-to-day life, we are going to come across with these neutralization reactions. We don't know those things are neutralization reactions, but still, when you go deep into the scientific explanation, an acid is going to react with a base to form neutral substances. So let's see what are those day-to-day examples for these acid-base neutralization reactions. Number 1, when acidity in the stomach increases, milk of magnesia is administered. Milk of magnesia means the base magnesium hydroxide. Milk of magnesia is a special type of a medicine. It's kind of a white color liquid, right? You are given with milk of magnesia to get some relief from gastroacidity. I think you could remember I explained about the gastroacidity, right? Gastritis, when I was talking about hydrochloric acid in the first place. Our stomach contains some amount of hydrochloric acid. So when you are going to starve for some time period, the acidity level is going to increase. So therefore a pain is going to occur. That pain is referred as the gastritis. It's mainly occurring due to presence of hydrochloric acid in our stomach. So to neutralize that hydrochloric acid level, you can administer magnesium hydroxide, which is a base. So when an acid is going to add with a base, you know that neutralization reactions are going to occur. Or when you drink or when you administer magnesium hydroxide or milk of magnesia, right, the acidity level of the stomach is going to reduce. So by that way you can get a relief from the pain. So here this base neutralizes the excess hydrochloric acid in the stomach. That's how you can get a relief from the pain due to gastritis by using magnesium hydroxide or milk of magnesia. Right, the second example. The pain caused by bee stings. The pain caused by bee stings disappear on application of lime. Now when you apply some amount of lime, right, the pain caused due to bee sting is going to disappear. Lime is a base, so definitely bee sting should be an acid, a type of an acid. Let's see. So when bee sting, acidic substances, so I told you, because lime is a base. If lime is a base, by applying lime, if we can get some relief, then the administered substance should be an acid. So here it is given, when bees sting, acidic substances are introduced into the skin, right? Into our skin, an acidic substance is going to introduced. So lime is a base, so it neutralizes the acid. That is why the pain subsides, right? That's why the pain is going to reduce or subsides, right? Then the next example, the wasp sting, right? Wasps are somewhat, like up to a certain level, somewhat dangerous rather than the bees, and somewhat larger wasp. So wasp sting is basic. It has a basic nature. Therefore, when an acidic substance such as vinegar or lemon juice is applied, so onto that place, right, where the wasp sting was administered, if you apply some amount of lime juice or vinegar, you can get a relief from the pain. It's because that wasp sting is basic. So acidic substances like vinegar or lemon juice can be used to minimize the poison level in our skin, because the poison, the basic poison, is getting neutralized by the acid. So the poison get neutralized and relieving the pain. So this is how the wasp sting works, my dear children. Wasp sting, if you take wasp sting, it has a basic nature. So when wasps are going to sting onto your skin, you need to apply an acid to get some relief. Okay, you need to apply an acid to get some relief. Then in the final one it is given, lime is applied to acidic soils. Lime, which is a base, neutralizes acids in the soil. Now before the cultivation, I think you have observed, quicklime or ash is added to the soil. Why do we need to add ash or quicklime into the soil before the cultivation of crops? Now, if you take rainwater, when it is going to rain for a long time period, rainwater is somewhat acidic, right? Rainwater is somewhat acidic. So when it is going to rain for a long time period, and if we are not cultivating, if we are not doing agriculture for a long time period, acidity in the soil will get increased due to collection of rainwater within the soil. So if you are going to cultivate in that kind of a land, there is a possibility that the crops will die. So to minimize this acidic soil, acidity level in our soil, we can add ash or quicklime into it. So by adding ash or lime, we reduce the acidity level in the soil, right? Acidity level in the soil. So how come we could reduce the acidity level? Because when you add in a base like ash or quicklime, it neutralizes with the acid present in the soil. So this is an example where we use neutralization reaction in our day-to-day life activities. So these are the examples for day-to-day activities for neutralization reactions, my dear children. Right then. So we came to the end of our lesson, my dear children. We discussed several things related. This is a pretty much longer lesson. We discussed several things related with the changes in matter. Now let's see what are the things that we have learned within this lesson part. So the changes takes place in matter is of two types, physical changes and chemical changes. Right, my dear children? So first of all, in the first and foremost chapter, we discussed about the physical changes and the chemical changes, right? So physical changes and the chemical changes. In a physical change, no new substances are getting created. Initial substances remains the same, right? There are no new substances which is getting created. For an example, a state change, right? So that kind of a thing is called a physical change. In a chemical change, new substances are getting created by the initial substances. And we refer those initial substances as the reactants, new substances as the products. So in a chemical change, new substances are getting created. In a physical change, the initial substances remains the same. In a physical change, the formation of or the nature of the substance remains the same, right? But in a chemical change, atoms or the particles rearrange to form new substances. Physical changes can be reverted back to original state, but chemical changes cannot be reverted back to original state, right? In the case of physical changes, the existing nature of matter changes, though its composition remains unchanged. Here, existing nature means the state or the size of the particle. That is getting changed in physical changes. But my dear children, the composition remain unchanged. Composition of the material, composition of the matter remains unchanged. The changes in which the composition of matter changes, giving rise to new substances, are known as chemical changes. So, composition of matter changes giving rise to new substances are called what? Chemical changes. Chemical changes. Then, rusting of iron, corrosion of metals, combustion of materials, neutralization are examples for chemical changes. We discuss all of these things: rusting of iron, corrosion of metals, combustion of a certain material, and finally neutralization. We discuss that all of these things are chemical reactions, right? Changes of state such as fusion. Fusion means turning a solid into liquid. Fusion, right? Turning a solid into liquid. Fusion. It is also referred as melting. Vaporization. Turning a liquid into gas. Turning a liquid into gas. Sublimation. Sublimation, turning a solid into a directly gas, right? Turning a solid directly into a gas. Sublimation. Condensation. Condensation means turning a gas into a liquid. Condensation. Turning a gas into a liquid. Condensation. And freezing. Freezing means turning a liquid into a solid. Turning a liquid into a solid. Are physical changes. So fusion. In fusion, solid is getting changed into liquid. It is also called as melting. Vaporization. A liquid is getting converted into a gas. Sublimation. A solid is directly getting converted into a gas. Solid into a gas. Sublimation. Condensation. A liquid, a gas, right? In condensation, a gas is getting converted into a liquid. And finally, in freezing, a liquid is getting converted into a solid. These changes are also state changes, means physical changes. Vaporization, sublimation, condensation, freezing, and there was another special one, deposition. What is deposition, my dear children? Deposition means converting a gas into a solid. Converting gas into a solid. The reverse process of sublimation, right? Sublimation means converting a solid substance into a gas. The reverse of that thing, converting gas directly into a solid, is called deposition, right? Okay. Heat change, evolution of a gas, formation of a precipitate, color change, heat and change in temperature or heat change provide evidence for the occurrence of a chemical reaction. Now, to provide a solid evidence whether there is a chemical reaction or not, we can give several, right, observations. These are that observations: heat change, evolution of gases, formation of a precipitate, color change, change in temperature. These things are going to provide evidences for the support of a chemical reaction. Then, the substances take part in a reaction are reactants. Reaction means chemical change. And the substances formed during a reaction are products. So in a chemical change, we discussed that reactants are getting converted into products. During chemical reactions, total mass does not change. That means the mass of the reactants that took part in the reaction is equal to the mass of the products formed after the reaction. So this is reflecting about the law of conservation of mass. In a chemical reaction, the entire mass of reactants and the products are getting conserved. So therefore, the total mass after a reaction and before the reaction in a closed system is a constant value. This is called as the law of conservation of mass. The reaction of combustible substances with oxygen is called combustion. When a combustible substance is going to react or is going to interact with oxygen gas, a combustion is going to occur, right? A combustion is going to occur. That is what do you mean by the combustion process. Then, when many fuels are subjected to complete combustion, during a complete combustion of fuel, right? Carbon dioxide gas and water vapor, right, are formed. Those are the two main products created during the combustion of a fuel. We did several experiments to show that carbon dioxide gas and water vapor are going to emit by using copper sulfate and hydrous copper sulfate. We took a good knowledge, or we took an idea about identifying these products, right? And also we use lime water to test with the carbon dioxide gas, right? So these are the main things that we learned in this lesson. So there are something which is left over in the final part. So here, during incomplete combustion, unburned carbon particles. So in a complete combustion, carbon dioxide gas and water vapor are the products which are getting created. Those are the products, that's it. In complete combustion, there is adequate amount of oxygen. There is enough oxygen to react with the combustible substance. In incomplete combustion, unburned carbon particles are there, and carbon monoxide, which is an intermediate product, right, is also there. Are also formed in addition to carbon dioxide and water. In addition to carbon dioxide and water, these intermediate products are also going to create. Unburned carbon particles means, my dear children, I told you, like ash, charcoal, those are unburned carbon particles. So carbon monoxide is an intermediate product during the incomplete combustion of fuel, right? And we discussed that during a complete combustion, more heat is going to emit, while in an incomplete combustion, less heat is going to emit. Complete combustion shows a blue color flame. Incomplete combustion shows a different color flame which is related to red or yellow color, right? The quality of heat generated during complete combustion is relatively higher than that generated during incomplete combustion. So we discussed that thing, right? The heat generated from complete combustion is greater than the heat generated from incomplete combustion. Water or water vapor and oxygen. So water vapor and oxygen are the essential factors for the rusting of iron. So after that we discussed about the rusting of iron. For the rusting of iron or for the tarnishing of metals, the most key important factors were oxygen gas and water vapor or water. Rusting can be prevented by methods such as applying paint, galvanizing, applying grease or oils. So here we avoid the contact of these two materials or these two factors with the metal surface, right? What are those two materials or what are those two factors? One thing is water vapor, and the second one is oxygen gas. So by applying paint, by galvanizing, and by applying grease or oil, we can avoid the contact of water and oxygen gas with the iron surface. So by that way we can prevent the rusting of iron. When an acid reacts with a base, then finally we discussed about the neutralization reaction, where an acid is going to react with bases. So when an acid reacts with a base, the acidic properties of the acid and the basic properties of the base disappear, right? So when an acid is going to react with a base, when a base is going to react with acid, both acidic and basic features are going to disappear. So we discussed that both acidic and basic features will going to disappear if you mix an acid with a base or else a base with an acid, right? The chemical reactions between acids and bases are called neutralization reactions. So finally we discussed about these neutralization reactions which a base is going to react with an acid. So when a base is going to react with an acid, both the basic and acidic features are going to disappear, and these types of reactions are referred as neutralization reactions, right? Neutralization reactions. And finally we discussed several examples, day-to-day examples for these neutralization reactions. Right then, so these are the things that we have learned under the lesson changes in matter, my dear children. So I hope that you got a sound knowledge about these topics, and let's meet with you with the next chapter to discuss some questions related with our lesson. So we'll memorize once again what are the things that we learned by doing some exercises. So first of all, we'll conduct some exercises, or we'll carry out some exercises from our textbook. Then after that, I'm going to give you some extra exercises to practice at your home to get some idea about this lesson. So my dear children, we'll meet with questions in our next chapter.